Hello, 7th graders, and welcome to Lesson 3.6 on applying rational number operations. What that means is we're going to be looking at some real-world applications of the operations we've been practicing so far in Chapter 3. This is going to look like a lot of word problems. Something we're going to work on is assessing the reasonableness of answers. How we're going to do that is we're always going to double-check our answers to see if they make sense. All right, example 1. John is hanging a picture. He wants to center it horizontally on the wall. The picture is 32.5 inches long, and the wall is 120.75 inch long. How far from each edge of the wall should he place the picture? Now notice they gave us a picture here. If they did not give us a picture, I would actually draw a picture so that you can visualize what's going on. So how would you even start drawing that? Well, you would draw the wall. The picture is 32.5 inches long, so there's the picture. You might do some dimensions there. That's 32.5. It's hard to write so tiny. And the wall itself is 120.75 inches long. And he wants it centered, so that means that this distance and this distance have to be the same. To figure out what each distance is, first we have to figure out how much space is left. To do that, we're going to find the difference of 120.75 and 32.5. So we're going to subtract those. Then we're going to take what we have left and divide it by 2. Or notice they multiplied it by 1/2. Same thing. All right, so how do you subtract the fractions? You need to find common denominators for the fraction parts, and then since 3/4 is actually bigger than 1/2, which is 2/4, you can subtract the whole numbers and then subtract the fractions. So 120 minus 32 is 88, and 3/4 minus 2/4 is 1/4. So our answer is 88 1/4 inch. That's how much space is left, but it's centered, so we want to know the length of the wall on each side of the picture. So now we're going to divide 88.25 by 2, or multiply by 1/2. And since this is a mixed number, you could either change that into an improper fraction or just multiply both by 2. So 88 divided by 2 is 44, and 1/4 times 1/2 is going to be 1/8, since when we multiply fractions, we multiply straight across. 2 times 4 is 8. So our final answer is going to be 44 1/8 inch. John should place the picture 44 1/8 inches from each edge of the wall. Now we're going to check the answer for reasonableness. The wall is about 120 inches long. The picture is about 30 inches long. So if we estimate, that means we have about 90 inches left. And then we know we have to divide it by 2 to find the space that should be on each side of the picture, which is about 45 inches. We estimate when we're checking the reasonableness because it's easier to estimate with whole numbers and say, oh yeah, that makes sense. 44 1/8 is about 45, so our answer makes sense. We could also plug 44 1/8 into our equations to double check our work. Checking the reasonableness is just as important. Okay, so your turn. I want you to read through this problem at the bottom, try to do it yourself, and then play the video back to see if you got it right. So pause the video, try number 1, then play it to see if you got it right. All right, I'm going to walk through it. So a 30-minute TV program consists of 3 commercials, each 2.5 minutes long, and 4 equal-length entertainment segments. How long is each entertainment segment? Okay, so what this is saying is I have 3 commercials that are all 2.5 minutes long, and then 4 equal-length segments. I don't know what those segments are, so I'm just going to mark it as X right now. And then all those added together should be 30 minutes. So first, I'm going to subtract the commercial length from 30. So 3 times 2.5, this might be easier to do as 3 times 2.5, which is 7.5. First, I'm going to subtract that. So 30 minus 7.5 equals 22.5. And now I know there's 4 equal segments, so now let's take 22.5 divide by 4, which is going to be 5.625, or 5 5/8. So our answer, each entertainment segment, is 5 5/8 minutes, or 5.625 minutes. All right, so we practiced a little bit with fractions. Now we're going to look at a problem that has both fractions and decimals. This is actually a very applicable real-life situation. We're dealing with baking. So if any of you have done some baking before, you've probably dealt with measuring cup fractions. Here's how it applies with cost value or money decimals as well. All right, so Alana uses 1 1/4 cups of flour for each batch of blueberry muffins she makes. She has a 5-pound bag of flour that costs $4.49 and contains 76 1/4 cup servings. How many batches can Alana make if she uses all the flour? How much does the flour for one batch cost? Well, there's actually two things we're solving here. The first thing we need to solve is how many batches can she make. Then we'll solve how much flour for one batch costs. Okay, so how many batches can she make? One batch is 1 1/4 cups, or we're actually going to say that that's 5/4. It's going to be a little easier to deal with as an improper fraction. She has a 5-pound bag that has 76 1/4 cup servings. So there's 76 1/4 cup servings. We're going to say 76 over 4. So we know 5/4 is 1 serving. There's 76 1/4 servings in there, which means there's 76/4. We need to figure out how many times 5/4 goes into 76/4. How we can do that? We're going to do 76 divided by 5. I'm going to set this up as long division. 5 goes into 7 one time. There's 2 left over. Drop the 6. And 15, and you have 1/5 left over. So the textbook actually solves this problem down here. They highlighted number of cups of flour in a bag, so instead of looking at the fourths, they did 76 times 1/4 is actually going to be 19 cups. So this number here is equal to 19. And then they took 19 and divided it by 5/4, which they got the same answer, 15.2. You have 15 1/5 batches in a 76 1/4 cup bag of flour. So her 5-pound bag can make 15.2 batches. This is the batches. All right, the second thing we're asked to solve is how much does the flour for one batch cost? Well, we know that whole bag costs $4.49. We also know that she can get 15 batches out of that bag. So we're going to take the cost of the flour, $4.49, divide it by 15. We're rounding down since she can't make 0.2 of a batch. And that's going to equal 0.29, repeating, or about 30 cents. So each batch costs about 30 cents in flour. All right, so we're going to test the reasonableness of this answer. This is what's happening down here in this justify and evaluate section. A bag contains about 80 1/4 cups, or about 20 cups. Each batch uses about 1 cup of flour, so there's enough for about 20 batches. That's math we can do in our head. 80, 20, 20 batches. A bag costs about $5, so $5 divided by 20 batches is about 25 cents. 25 cents is pretty close to 30 cents, so our answer makes sense. If you got, say, $2.50, you probably carried a decimal wrong, and if there's 20 batches in a $4.50 bag, and each batch is supposed to cost $2.50, that doesn't make sense. That's not reasonable. That's why we estimate to check for reasonableness to see if our answer makes sense. All right, example 3. The depth of Golden Trout Lake has been decreasing in recent years. 2 years ago, the depth of the lake was 186.73 meters. Since then, the depth has been changing at an average rate of negative 1.75% per year. What is the depth of the lake today? Well, the first thing we're going to do is convert that percent to a decimal. When we start doing our operations, it's going to be a lot easier to operate with a decimal than with a percent. So negative 1 3/4 is the same thing, 3/4 is the same thing as 0.75. So first, we're going to change that to negative 1.75%. And then we know to move a percent to a decimal, we're going to move the decimal point 2 places left. So notice that decimal point moved 2 places left, and now it's 0.0175. You can also do that by dividing by 100. Now this happened 2 years ago, it says. So while we could just multiply that by 2, it's going to be easiest to find the change 1 year later and then repeat the operations we did to find it 2 years later. So next we're going to find the depth of the lake after 1 year. You can use a calculator. You don't need to multiply all these decimals in your head, but we're going to take the depth that it started at and then multiply it by the change. Again, this is the change, not the depth. So it changed. It went down 3.27 meters. Then we find the new depth. So we're going to subtract 3.27 from where we started. And our new depth is 183.46. So we find the change, the percent decrease. And then we subtract that from where we started to get what the new depth is. And so now we're just going to repeat that. Notice that 183.46 is now the number we're starting with. So I have 183.46. We're going to find the change, so multiply that by the percent decrease. It went down 3.21 meters. Now we're going to subtract 3.21 from 183.46, and we get our new depth. So the new depth is 180.25 meters. All right, to check the reasonableness here, again, we're going to estimate. The original depth was about 190 meters. You might also round this to about 200 to do easier math in your head. The depth changed by about 2% per year, went down about 2%. We know 2% of 100 is 2, so 2% of 200 would be 4. So it should have went down about 4 meters in 1 year and then 8 meters in 2 years. So the new depth should be about 182, which is pretty close to the estimate, 180.25, so it is reasonable. All right, so here's another point where I would like you to pause the video, try number 3, this your turn up here by yourself, and then play it back to see if you got it right. I'm going to go ahead and solve it. 3 years ago, Jolene bought $750 worth of stock in a software company. Since then, the value of her purchase has been increasing at an average rate of 12 3/5% per year. How much is the stock worth now? Okay, so this was 3 years ago. So like in the last problem, how we did it twice, this time we're going to repeat our steps 3 times. So it started at 750, and then we're going to multiply that by 0.126. That, by the way, is 12 3/5% as decimal. I'll write that up here. Equals 0.126, because 3/5 is 6/10, or 0.6, which 12/6. Okay, so we're going to multiply those, and the change in 1 year was $94.5. It went up that many. So now we add them to find what it was after year 2. So 750 plus 94.5 is going to be 844.5. So now we repeat that. We do 844.5 times 0.126, add it to our answer, and then repeat it one more time. Your final answer should be 1,070.72 All right, so this guided practice we're going to do together, and then your homework will be on the next page. So problem 1, Mike hiked to Big Bear Lake in 4.5 hours at an average rate of 3 1/5 miles per hour. Pedro hiked the same distance at a rate of 3 3/5 miles per hour. How long did it take Pedro to reach the lake? Okay, so first we're going to find the distance Mike hiked, and so he did 4.5 hours at a speed of 3 1/5 miles per hour. We're going to convert 1/5 to a decimal, which is 0.2. So now we have 4.5 times 3.2 miles per hour. So Mike hiked 14.4 miles. By the way, guys, it's okay to use your calculator here. I am also using my calculator to find these answers. You do not have to multiply these decimals in your head. Okay, so now we're finding Pedro's time to hike the same distance. So now we're going to start with the miles, 14.4 miles, divide by the miles per hour. We're going to convert 3 3/5 to a decimal, or 3.6, and it took Pedro 4 hours to hike 14.4 miles. Okay, next problem. Until this year, Greenville had averaged 25.68 inches of rainfall per year for more than a century. This year's total rainfall showed a change of -2 3/8% with respect to the previous average. How much rain fell this year? Well, first we're going to convert that percent to a decimal. So I know 2 3/8 is 2.375. And if the decimal is after the 2, I move it 2 spaces to the left to find my actual decimal. So 0.02375 is the change with respect to last year's average. So last year's average was 25.68, and we're going to multiply that by 0.02375, which is 0.61 inches. I'm rounding. So it's 0.61 inches different. Now we're going to subtract it. So again, the average was 25.68. Since we know what the percent decrease was in inches, now we're going to subtract those inches. And this year's average was 25.07 inches of rainfall. All right, so question 3 just asks us to reflect a little bit. Why is it important to consider using tools when you're solving a problem? In these cases, we used a calculator. So it's important to consider using a calculator because you don't want to multiply 0.02375 times 25.68 in your head. You could, but a calculator is going to make it a lot faster for us. And again, always check the reasonableness of your answers. All right, your homework today is to do numbers 4 through 7 all. So you have 4 problems. You're going to do all of them. They're word problems. Please email me if you need any help.